In this activity, we'll be finding the roots of a quadratic equation. The objective of this activity is to find the roots of the quadratic equation x square plus 2x minus 15 equal to 0 by paper cutting and pasting method. Let's see the concept in hand first. Whenever you have a quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0, it has two roots or two solutions. The roots can be real or complex depending on some criteria. But for this activity, we are taking up the roots which are real. So when do we have real roots and how many real roots are there for a quadratic equation? That is dependent on its discriminant b square minus 4ac. We can actually find the two roots of any given quadratic equation where the roots are real by using a square strip of paper. Yes, a square strip of paper. And if you can divide this paper into a definite number of parts using some criteria which we will see in this activity, you can actually find the roots or the real roots of a quadratic equation. What is the material required for this activity? We require some colored papers, geometry box for measurements, a pair of scissors for cutting, and glue for pasting work. Let's see how we can find the roots of a quadratic equation using this activity.
So we will be attempting to find the roots of this quadratic equation x square plus 2x minus 15 equal to 0 using this activity. In this activity, we require a cutout in the shape of a square of 3 units side. That means the length of the side can be either 1 centimeter or 1 inch also. So this is 3 units by 3 units. Then we require another cutout whose dimensions are 3 units by 1 unit. So we have 3 squares on it. And similar to that, we have another congruent figure. So 2 figures of the same size, and there is a 1 by 1 small square which is also required in the activity. Now what do we have to do with all these cutouts is we will be placing or pasting this 3 by 3 square here on a sheet of paper, and then pasting this at the bottom here like this, and then pasting this here like this, and the final cutout will be filling this empty space here. So this forms a big square. So if you assume that this side is x, then this side is 1. So the side of the larger square is x plus 1, and therefore the area of the larger square is x plus 1, which is the side whole square. This is the area of this big square. Now how do you tackle this after this? Just count the number of squares along the length now. 1, 2, 3, 4. 1, 2, 3, 4. So we have 16 squares here. So this area is actually equal to 16. Now if x plus 1 whole square becomes equal to 16, then we can cancel the square and take this in the square root. Therefore x plus 1 will be equal to plus minus 4. And then when we equate this x plus 1 with 4, you will get the first root, that is x equal to 3. And when you equate x plus 1 with negative 4, you get the second root, x equals negative 5. And therefore the roots of this quadratic equation are 3 and negative 5, which is obtained through the activity.